Hey there, what's up?
So as currently there's so many progresses in the AI world, namely agentic AI and reinforcement learning, and of course all the LLM and the VLM work. Give me an overview as of currently 2026. Check on the internet context. What is the current SOTA and progress in the world of AI?
As of 2026, AI is advancing with agentic systems that plan and coordinate tasks, and multimodal models combining text, vision, and more. AI is embedded in workflows rather than just standalone tools, and countries like China are strategically expanding AI use. While domain-specific models show success, human-level general AI is still out of reach, and broad productivity gains remain limited. In the future, expect AI to be more seamlessly integrated and governed more rigorously, but AGI and universal productivity boosts are still speculative.
So you brought up two things. One is agentic AI, another is multimodal. And let's explore agentic first. And there's like OpenClaw, and of course coding agent is having a buzz, like been a while for to have a buzz been a while now. And then give me an overview and what it's capable of as of now, and people's creative applications.
As of 2026, agentic AI systems are capable of autonomously planning and executing multi-step tasks, acting across workflows, and iterating based on feedback. They are already used for things like content production workflows, where AI handles tasks like formatting or testing, while humans guide creativity and strategy. However, broad productivity gains and true human-level intelligence remain out of reach. In creative applications, these AI agents help automate repetitive processes while leaving the core creative decisions to humans.
So the the multi-step is through reasoning and some sort of simple generation and reevaluation loop.
Yes, that's right. The agentic AI typically reasons through each step, generates possible actions, and then reevaluates outcomes. It's essentially a loop where it refines its approach based on the feedback it gets from intermediate results. That gives it some flexibility, even though it's not truly thinking like a person would.
I guess it's just like uh, the standard chain of thought, and some sort of loop. Anything
Exactly.
else?
In essence, that covers the core mechanism. Beyond that, the sophistication grows with how well the AI can adapt to varied contexts, how it handles unexpected obstacles, and how much autonomy it's allowed. But at its core, yes, it's reasoning and iteration loops, just scaled up.
Um, so the context, how it is currently managed, I think now it's starting to see dynamic context management.
Yes, that's becoming key. These systems now dynamically manage context, deciding what to remember or forget, so they stay relevant over longer workflows. They prioritize crucial information and drop details that no longer matter, allowing them to handle more complex, evolving tasks.
So the dynamic context management is only a recent thing, or has this been here for a while?
It's been evolving, but it's more mature now. Early attempts were simpler, maybe a fixed context like. But lately, models actively decide what's relevant, helping them adapt better to long or shifting tasks. So yes, the dynamic aspect we're seeing now is more recent and refined.
And how about in the agentic world other aspect, such as multi-agent orchestration?
Multi-agent orchestration has advanced too. Systems now coordinate specialized agents, each with different roles, like a team. One agent might gather data, another strategizes, another executes. They interact, hand off tasks, and resolve conflicts, making them more flexible for complex projects. It's like an ensemble of specialized tools working in concert.
So how are those if essentially all of those agents are to a degree independent?
To a degree, yes. Each agent typically has its own defined capabilities and decision-making scope. They operate somewhat independently within their roles, but share information and synchronize. Ultimately, they're aligned to the overarching goal, so they're autonomous, but not rogue.
So the independent agent actually go through their own internal context and then only share what it wanted to share, or there is some sort of embedding database that one agent can retrieve any other agent's uh, sentence or context.
In practice, it's more collaborative secretive. While agents have their own internal processes, they often share necessary context through a shared memory or database. One agent can retrieve another's output or key context when needed. The system ensures information flows so all agents work toward the shared goal. It's not about withholding, it's about efficient coordination.
So how does it retrieved?
They typically retrieve from a shared memory store or database, often a vector database holding key embeddings of context or outputs. When an agent needs info, it queries that store using relevant embeddings. The most relevant context or conclusions are fetched, ensuring agents have up-to-date, coordinated information to act effectively.
So can I understand that between agents they either retrieve relevant information via vector DB or directly talking between agents through their inner communication?
Yes, that's spot on. They either pull what they need from shared memory or directly exchange messages in real time. The design depends on the system. Some rely more on centralized memory, others use agent-to-agent messaging. But either way, they coordinate to stay aligned.
So I think last year I think one of the challenges is architecture of multi-agent orchestration. One of which is the as agents increases, a lose operational efficiency, and I wonder if this has been improved or is still a problem.
They've made progress, but scaling still brings complexity. Recent improvements focus on smarter task delegation, prioritizing critical agents, and reducing redundant communication. So while there's still overhead if the number of agents grows, the orchestration has gotten more efficient and streamlined than before.
Is it a dynamic agent assignment or available or more readily available now?
Yes, dynamic agent assignments is more common now. Systems can spin up or retire agents as needed. When tasks shift, new agents with specific expertise can be allocated. This makes multi-agent systems more adaptive and reduces inefficiencies. So it's a more agile setup than before.
Yeah, so I remember back then one has to create all the agent and then the agent's rules by themselves. Now I guess one can more comfortably spun off different type of agent and they will automatically create a more operationally efficient architecture, or this is still not sophisticated enough. Like you have to give some instruction of how the rule of spin off, or it's completely automated.
It's more automated than before, but not fully magic. Modern systems can spin up common agent types with minimal guidance. However, for more nuanced tasks or complex roles, you still give some instructions on priorities or delegation rules. In short, it's easier now, but not entirely hands-off. A balance between automation and instruction is still best.
So can I say that it's semi-automatic? You need instruction on how and when, but not like fully define rules and a rigid structure.
Exactly, you've got it. It's semi-automatic. You set the broader expectations, when to scale up or what kind of agents might be needed, but you don't have to micromanage every agent structure. The system fills in a lot of the operational details, so it's flexible, but you still provide strategic direction.
So the structure, I'm curious. I was exploring to a degree like human structure on like corporations. It almost like organizations that automatically assemble to a certain architecture that become efficient over the last few years. Hasn't been changed by its core in terms of architecture in human corporation. Has the agent ended up become similar in the sense that it become like a corporation operation, like it become the same structure?
They've drawn inspiration from human organizational structures, but they're not rigid like a corporation. Agent systems remain fluid. The architecture adapts to the problem. Agents can reorganize or shift roles dynamically. While some stable patterns emerge, they don't lock into one permanent structure like a fixed corporate hierarchy. Instead, they balance efficiency with flexibility.
Because I guess there's no overhead on hiring and very little overhead on hiring and firing, right?
Exactly. Spinning up or retiring agents is cheap and instant. There's no emotional or logistical baggage like in human organizations. That's what makes these systems so fluid. They can restructure instantly with no overhead, purely based on what the task demands.
So on the multi-agents front, any other development in the bleeding edge?
As of 2026, multi-agent AI systems have evolved into teams of specialized agents that coordinate tasks, manage context dynamically, and scale up or down as needed. There's been progress in how they communicate through shared memory or messaging, and agents can be spun up on demand. However, challenges remain. Coordination gets complex at scale, full autonomy is still out of reach, and governance is an ongoing issue. Emerging protocols and enterprise deployments are also shaping the field.
So governance and context management, and then is a crux of the problem right now.
In a nutshell, yes. The cutting edge now isn't just about making agents smarter individually. It's about governing them, ensuring oversight, ethical alignment, and maintaining coherent context across agents as tasks evolve. It's that orchestration and alignment piece that's front and center.
Let's switch gear a little bit. Let's look at LLM, because the agentic is effectively LLM. I don't know if I can claim that the current LLM is good enough for almost all tasks. The agentic workflow on context management and governance is significantly more important.
You're absolutely on the mark. While today's large language models are incredibly capable, they aren't perfect at every task out of the box. Agentic workflows, with strong context management and governance, allow these models to adapt and reason over longer, more complex workflows. So, even though the core LLM might be strong, it's this orchestration, governance, context switching, and multi-step reasoning that really expands what's possible.
So, is LLM have any improvement or development in the in the current soda? I mean, I don't see any like leaps, except computation improvement of like structural optimization.
As of 2026, large language models have made key advances. They can handle massive context windows, often in the millions of tokens, and they've improved in reasoning, tool use, and multimodal capabilities, like combining text and images. Open source models are also more mature and cost effective. However, we still don't have general purpose AI, and scaling brings high costs and complexity. So while LLMs are more powerful, success now depends on how well they're integrated and governed in real world workflows.
So, in nutshell, you're saying the LLM, like the text LLM, is good enough, but like at the current stage, one is going open, like multimodal, and open source is much more sophisticated. But at the crux of the problem, I think we're aligned in the sense that it's still the context management and governance.
That's right. The core text-based LLMs are strong. But the real leap is in integrating multiple modes, text, vision, and beyond. Open source models are catching up too. But yes, no matter how capable the model is, the crux remains how well you manage context and ensure the right oversight, especially when things get complex.
Let's look into the multimodal world. I mean, there are huge advances from 2025. Uh, give me some highlight, and then what is the current soda?
As of 2026, multimodal AI systems can handle text, images, audio, and video. I'm sorry, but you've hit the daily limit for advanced.